Good day everyone, my name is Eva Irish Camilleri and I will be discussing Scanning Tunneling Microscope or STM. Before everything else, let us define what is Scanning Tunneling Microscope. The Scanning Tunneling Microscope or STM is an electron microscope that transmits 3D images of the electron cloud around the nucleus. The scanning tunneling microscope allows the inspection of the properties of a conductive solid surface and atomic size. It is a very important technique in determining the atomic structures and electronic states of the surface under investigation. Surfaces can be viewed at the atomic size thanks to the high resolution or zero point 0.1 atoms the STM has. But who made this high resolution microscope and who are the proponents? The Scanning Tunneling Microscope or STM is a special type of microscope that was invented by scientists named Gerd Binning and Heinrich Rohrer. It's used to see things that are extremely small, like atoms. The invention deserved a Nobel Prize for Physics in 1986. On October 1986, the soccer team of IBM Zurich Laboratory and Down Chemical played a game which had been arranged earlier. To everyone's surprise, a few hours before the game, the Swedish Academy announced the Nobel Prize for Gerd Binning and Heinrich Rohrer. The STM has 5 components. First is its metal tip, second is piezoelectric scanner, third is current amplifier, fourth is the bipotentiostat, and fifth is the feedback loop. The STM works by using a tiny metal tip that is very sharp like a needle. The scientists made this tip by using a special process called electrochemical etching. They started with a wire made of material called tungsten and used a chemical solution to gradually make it thinner and thinner until it was just 1 atom thick. To make the microscope work properly, the scientists had to deal with the problem of vibrations. Even small movements or vibrations could mess up the images they were trying to see. So, they used magnets to make the microscope float and stay stable. In addition, the STM relies on quantum tunneling effect. It is the energy of an electron exceeds its total energy. It can penetrate regions which are possibly according to classical physics. This is called tunneling. The STM relies on a principle called quantum tunneling. Atoms, which are the building blocks of everything around us, behave in strange ways at the tiniest level. One interesting behavior is called the quantum tunneling. It means that electrons, which are the particles that orbit around an atom's nucleus, can jump from one place to another, even if there is barrier in between. Binning and Rohrer took advantage of quantum tunneling in the STM. They made the metal tip and the sample they wanted to study have different electrical charges. This caused electrons to jump between them, creating a tiny electric current. By measuring this current, they could tell how close the tip was to individual atoms on the sample surface. Using the scanning tunneling microscope, Binning and Rohrer were able to create images that show the arrangement of atoms on a surface. It was the first time scientists could directly see individuals' atoms. This was a huge breakthrough in science and opened up new possibilities for studying and working with materials on a very small scale. Here are the advantages of scanning tunneling microscope. STM are versatile. They can be used for ultra-high vacuum air, water, and other gases. STM works faster than atomic force microscopes. Resolution of STM is much better than atomic force microscope. STMs are helpful because they can give researchers a three-dimensional profile of surface which allow researchers to analyze a multitude of characteristics, including roughness, surface defects, and determining things about the molecule size and conformation. It is capable of capturing much more detail than other microscopes. This helps researchers better understand the subject of their research on molecular level. Scanning tunneling microscope works faster than atomic force microscopes, and they will activate in temperatures as low as 0 Kelvin up to a few hundred degrees Celsius. And lastly, resolution of scanning tunneling microscope is much better than atomic force microscope. Of course, there are few advantages by using a scanning tunneling microscope. STMs can be difficult to use effectively. There is very specific technique that requires a lot of skill and precision. STM requires very stable and smooth surfaces, excellent vibration control, and sharp tips. STMs use highly specialized equipment that is fragile and expensive. And although STM analysis only conductive materials, AFM uses for conductive and insulator materials. And STM requires vacuum atmosphere, but AFM can work even in liquid. For that reason, AFM can be used for biological materials. That would be all for scanning tunneling microscope. Now let's proceed to nanomanufacturing. Now, let's proceed to nanomanufacturing. So what is nanomanufacturing? Nanomanufacturing is a set of industrial processes based on nanotechnology, where products are developed at the nanoscale. Nanomanufacturing is like making really tiny things. We're talking about the things that are so small that you can see them with your eyes. These tiny things are made on scale that is a billion times smaller than a meter. Scientists and engineers use special techniques to create these tiny materials and structures, and they can be used in all sorts of cool stuff like computers, medicine, and energy devices. Nanomanufacturing has two approaches. First is top-down approach, and second is bottom-up approach. The top-down approach consists of reducing large pieces of materials all the way down to the nanoscale. An example of this is nano-imprint lithography. The top-down approach is like starting with something big and making it smaller, like when you carve a big piece of clay into a small shape. In nanomanufacturing, scientists take a larger object and use special tools and techniques to cut, shape, or modify it until it becomes really tiny. An example of top-down approach is making computer chips. At first, engineers start with a big piece of a special material called silicon. Then they use special tools and techniques to carve and shape it into really tiny parts that make up a computer chip. These tiny parts help the computer chip do all sorts of amazing things like storing information and running programs. Now, nano-imprint lithography. It is a process where you use a special stamp to press tiny patterns onto a surface. It's like using a rubber stamp to make a pattern on paper, but on a much smaller scale. The stamp has very tiny features that get imprinted onto the surface, creating a pattern. Imagine you have a rubber stamp with a tiny picture of a smiley face on it. If you press the stamp onto a piece of clay, the smiley face pattern will get imprinted on the clay. Nano-imprint lithography works in a similar way, but instead of clay, it's done on a nanoscale and uses special materials and surfaces. Let's move forward to bottom-up approach. The bottom-up approach is like building something from the smallest part up to something bigger. It's like playing with building blocks. You start with the tiniest blocks and put them together to make bigger structures. In nanomanufacturing, scientists use tiny building blocks called the atoms and molecules. They carefully arrange and combine these atoms and molecules until they form bigger structures with special properties. An example of this is making tiny particles called nanoparticles. Scientists start with really small bits like atoms and use special reactions to make them stick together from these nanoparticles. It has unique properties and can be used in things like medicines or to make chemical reactions happen faster. Chemical vapor deposition. It is a process in which chemicals react to produce very pure, high-performance film. Imagine you have some special chemicals that you want to turn into a solid material. In CVD, these chemicals are mixed together and then heated up. And when they get really hot, they turn into a gas or vapor. This vapor is then carefully deposited onto a surface like a film strip. It's like when you blow hot air on a window and the steam from your breath makes the glass foggy. CVD is used to make film strips with materials like silicon, carbon, and filaments. Next is deep pen lithography. It is a technique that uses a tiny pen-like tip filled with special chemicals to draw or write on surfaces. It's similar to using an ink pen but on a much smaller scale. The tip is dipped into this chemical and then used to create very small patterns or even electronic devices on surface. It's a precise and powerful way to make tiny structures. The other one is self-assembly. It is a process where different elements or molecules come together without any help to form a structure. It's like when puzzle pieces fit together on their own to create a picture. In self-assembly, the elements or molecules are designed in a way that they naturally arrange themselves into a specific shape or structure. It's a fascinating way to create things without having to manually put each piece in place. Other techniques is molecular beam epitaxy. It is used to deposit thin films. In molecular beam epitaxy, we shoot individual atoms or molecules at a surface to build a thin layer, like shooting tiny building blocks to make a structure. Next is atomic layer epitaxy. It is a process where layers comprised of single atomic thickness and are deposited onto surfaces. Atomic layer epitaxy is like building a tower brick by brick. We add one layer of atoms at a time in a very precise way to create a thin film. It's all about careful control and putting each atom in the right place. In summary, nanomanufacturing is about making really small things, and the bottom-up approach is like building from tiny blocks, and the top-down approach is like making something big smaller. Scientists and engineers use these approaches to create amazing things that help us in many different ways, from medicine to computers.
Good day, I am Alkea Cambronero, and today we are going to discuss about electron microscope. So electron microscope is a type of microscope that uses a beam of accelerated electrons to illuminate a specimen rather than light. The wavelength of electrons is much shorter than that of light, allowing for much higher magnification and resolution than a traditional light microscope. The electron microscope was invented by a team of German engineers led by Max Knoll and physicist Ernst Ruska in 1931. Ruska received the Nobel Prize in Physics in 1986 for his contributions to the development of the electron microscope. There are two main types of electron microscopes. First, we have transmission electron microscopes, or TEM. In a TEM, or TEM, the electron beam passes through an ultra-thin specimen, which is typically sliced thinly to allow electrons to transmit through it. The specimen interacts with the electrons, and the transmitted electrons form an image on a fluorescent screen or digital director. TEMs are commonly used to study the internal structure of cells, tissues, and materials at very high magnifications. Next, we have scanning electron microscope, or SEM. In a SEM or SEM, the electron beam scans across the surface of a specimen. The interactions between the electrons and the specimen produce signals such as secondary electrons, backscattered electrons, and X-ray. These signals are collected and used to create an image of the specimen's surface. SEMs are widely used to study the surface morphology and composition of material. Electron microscopes are essential tools in various scientific fields, including biology, materials science, nanotechnology, and physics, due to their ability to visualize objects at the nanoscale level. They have greatly contributed to our understanding of the structure and properties of a wide range of materials and biological specimens. Next, we have atomic force microscope. An atomic force microscope, or AFM, is a type of high-resolution scanning probe microscope that is used to create images of nanoscale surfaces. It operates by scanning a sharp probe over the surface of a sample, measuring the interaction between the tip and the sample surface. The atomic force microscope, or AFM, was invented by Gerd Binning, Calvin Craig, and Christoph Gerber in 1986 at IBM's Zurich Research Laboratory. Their groundbreaking work on the AFM led to the development of a powerful tool for imaging and manipulating matter at the nanometer scale. An AFM uses a cantilever with a sharp tip to scan a sample, bending due to forces between atoms or molecules detected by a laser and reflected onto a photodetector. The AFM still uses the cantilever deflection to create surface maps revealing atomic level details, enabling material topography study, force measurement, and atom or molecule manipulation. AFMs are widely used in various fields such as materials science, biology, nanotechnology, and surface physics for their ability to provide detailed images and measurements at the nanometer scale. They have contributed significantly to our understanding of nanoscale structures and properties.
Hello, good day everyone. My name is Lawrence Ivan Brakel from BS Ed English 2A. I am one of the members of the Group 7 and we are tasked to report about the Nanoworld. And today I am going to discuss about the distinct features of the nanoscale. When we are talking about the distinct features of the nanoscale, we are dealing with their unique properties, their characteristics that only exist at the nanoscale. Okay, so the first characteristic is, of course, its small size. Nano refers to 1 billionth of a meter. Therefore, nanoscale materials and structures are extremely small. To give you a hint about how small the nano size really is, I have here an illustration. I have here a penguin, and let's call him Mario. Then, si Mario nado siya size nga or height nga 1 meter. And then, if we're going to zoom in sa balahibo ni Mario, makakita ta og garapata or a tick. And the size of garapata is 1 in 1,000 of a meter or 0.001 meters. And if we're going to continue to zoom in sa garapata ni Mario, naatay makita nga bacterium nga nitapot sa iyang lawas. And the size of that bacterium is 1 millionth of a meter. If we're going to continue to zoom in sa bacterium nga nitapot sa garapata ni Mario, we can see its DNA. And the size of its DNA is 1 billionth of a meter. And that is equivalent to 1 nanometer. Can you imagine how small the nanoscale really is? This nearly invisible world can be viewed only by an atomic force microscope. The second distinct feature is large surface area to volume ratio. Nanoscale materials have a high surface area compared to their volume, which can lead to unique properties and interactions. Since ang mga nanoscale materials are relatively small, therefore gamay lang po ng ilahang makover nga space. And that's why they have large surface area compared to their volume. And we were talking about volume, it refers to the amount of space occupied by the material. This increased surface area can lead to enhanced reactivity, improved absorption capacity, and unique surface interactions, which are valuable properties in various applications of nanomaterials. If you would ask if asa magamit ang mga nanomaterials, we will discuss it later. Okay. Then ang impact sa large surface area to volume ratio could lead to another distinct features which we call the enhanced properties. Okay. Nanoscale materials can exhibit enhanced properties such as increased strength, conductivity, and reactivity. An example for that is a carbon nanotube. It is very small but it is more durable than its larger counterparts. Wanna know how and why? Okay. Imagine if naa kay papel. Pag ang papel is flat lang siya, wala nimo siya gipilo, therefore dali ra siya mag-bend, dali ra siya magtiko-ko. But if we are going to fold the paper and make it smaller and smaller, and as we keep folding, we will notice nga ang paper kay magkaanam siya kagahi, magkaanam na siya og strong. And this is similar to what happens at the nanoscale. And this phenomenon is called quantum confinement. And it refers to the phenomenon that occurs when particles such as electrons are compressed or confined in a very small space such as a nanoscale structure. Okay. Let's imagine nga ang kanang mga lines nga nasa atong paper is mao na siya ang mga electrons or mga particles. And while ginapilo nato ang papel, we are confining those particles into the very small space. Similarly, carbon nanotubes have a tabular structure composed of multiple layers of carbon atoms that makes them stronger than larger carbon structures. Then, they are usually incorporated sa mga polymers, sa mga metals, or sa mga ceramics para ma-increase ang ilang strength o durability, which are utilized in aerospace and automotive. Okay. The fourth one is manipulation and control. Why is this a distinct features of the nanoscale? Nanotechnology allows for precise manipulation and control of materials at the atomic and molecular level. To manipulate and control materials at the atomic and molecular level, scientists will and should utilize nanotechnologies to do so, for the purpose of studying what are the unique properties that they can learn about the nanoworld that they can imitate its functions for specific applications. By precisely arranging atoms and molecules, they can engineer or the scientists can engineer materials with specific properties. Tailoring these properties enables the creation of materials that meet desired requirements for specific applications. Okay. Ang mga scientists, they are using nanotechnology to observe materials at the nanoscale. And then, kung unsa ilang mga information nga mag-gather dito or makita, they are going to study about that and then make use of that and apply it to a lot of things na makabenefit ang humanity. And that's not the only one that they can do. Na maka-manipulate na po sila, maka-control sila og mga materials, mga atoms, or mga molecules para ma-arrange ang specific properties to create materials that meets the desired requirement for specific applications. Number 5, potential applications. Nanoscale materials and structures have the potential to revolutionize various fields, including electronics, medicine, energy, and material science. One example of that is the flexible devices. Nanoscale materials like nanowires and nanocomposites They can be used to create flexible electronic devices. Opens a new possibility of creating electronics with our wildest imaginations. Okay. So, ang mga flexible devices, it opens for portability, comfortability, nga maskin pag imo siyang bali-balion or i-twist nimo, dili mawala iyang functionality. Try daw twist ang imong phone karon, di ba? Mawala ang function ana kay madaot imong phone. Try nimo hulog imong phone, kay tendency nga maguba imong phone. But with flexible devices, we can create lightweight materials and we can make use of nanoscale materials and nanowires and nanocomposites to formulate new electronic devices that opens doors for portability and new possibilities of electronics with our wildest imaginations. And the next one is targeted drug delivery. Nanoscale materials can be designed to carry and deliver drugs to specific target sites of the body. They can selectively bind to diseased cells or tissues, improving drug efficacy and reducing side effects. Okay. Di ba pag natay sakit, na mga cells ana or mga tissues nga affected ana. And if we're going to take medicines, na ay tendency nga ang katong mga healthy cells or mga healthy tissues is madamay na siya sa side effects sa mga tambal nga tuwang giinom. And with this targeted drug delivery, it solves that kind of problem. Kaya ang mga nanoscale materials, because of how small they are, they can deliver drugs to the specific cell or tissue para ma-reduce ang side effects o ma-improve ang drug efficacy. And matarget jud ang dapat matarget o dili madamay itong mga healthy cells or tissues. So now, let's discuss about the benefits of using nanotechnology. Nanotechnology offers numerous benefits and has the potential to revolutionize various fields. Number 1 is improved materials. Nanotechnology enables the design and engineering of materials with enhanced properties. By manipulating materials at the nanoscale, scientists can create materials with improved strength, conductivity, flexibility, and other desired characteristics. Okay, to discuss na ako ganiha nga ang mga scientists, they are going to use nanotechnology to arrange materials at the nanoscale to create materials with improved strength, conductivity, flexibility, and other desired characteristics depending on how they are going to use them. Number 2, enhance healthcare. Nanotechnology has the potential to revolutionize healthcare by enabling target drug delivery, improve diagnostics, and regenerative medicine. Na-discuss na po na kung sa target drug delivery, which is ang katong paggamit og nanoparticles to deliver drugs sa specific cells or tissues nga affected para ma-increase ang effectiveness sa medicines nga atong ginatake and also ma-lessen ang side effects sa mga medicines nga gina-intake sa atong lawas. And then it also enables to improve the diagnostics and regenerative medicine. Nanosensors can detect diseases at an early stage, leading to timely interventions. So, ang picture nga nakita ninyo diri, mas mauna siya ang nanosensors. This is for detecting diseases para makabuhat dahil interventions ang mga doctors and maagapan dahil kung unsa man ang naasakit. Kung unsa man ang naay sakit sa inyo. Okay. Nanosensors can detect diseases at an early stage, leading to timely interventions. So, ang picture nga nakita niyo diri is noon siya ang nanosensors. Ginagamit ni siya para ma-detect dayon kung unsa man ang inyong mga sakit at an early stage para maagapan ni dayon siya. Additionally, nanomaterials can also be used in tissue engineering to create artificial organs or promote tissue regeneration. Number 3. Environmental sustainability. Nanotechnology offers solutions for environmental challenges. It can be used for water purification, air filtration, and remediation of contaminated sites. Nanomaterials can efficiently remove pollutants, filter harmful substances, and degrade environmental contaminants, contributing to a cleaner and healthier environment. Considering na atong environment karon is full na of pollution, nanomaterials is one of the solution para ma-address ni nga issue. Because all of us deserve to have a clean water and filtrated air para malayo ta sa mga sakit and pollutions. Number 4, electronics and computing. Nanotechnology has revolutionized the electronics industry by enabling smaller, faster, and more efficient devices. Nanotechnology aims to create smaller, faster, and more efficient devices. Nanoscale components such as transistors and memory devices have enabled the miniaturization of electronics and the development of powerful computing systems. Nanotechnology also facilitates advancements in flexible and wearable electronics. Same here with what you have seen in the picture. This is an example of wearable electronics. Number 5, food and agriculture. Nanotechnology has the potential to improve food safety, packaging, and agricultural practices. Nanosensors can detect contaminants in food, ensuring its quality and safety. So, ang mga nanosensors, they can detect contaminants in food para ma-check ang quality sa food as well as ang safetyness. In agriculture, nanotechnology offers possibilities for targeted delivery of fertilizers and pesticides, improving crop yield and reducing environmental impact. So, ang nanotechnology also plays a big role in terms of agriculture. Now, let's talk about the concerns of using nanotechnology. Number 1 is health and safety. There is a need to understand the potential toxicity and long-term effects of exposure to nanomaterials, especially in occupational settings or through consumer products. Proper handling, disposal, and risk assessment protocols are essential to ensure the safe use of nanotechnology. Kanina na-mention na ako nga ang nanotechnology has the potential to revolutionize the healthcare by enabling target drug delivery, pero ang proper handling, disposal, and risk assessment protocols kay need na siya para ma-ensure ang safe use of nanotechnology. Because kung mo gamit ang nanotechnology, ito mong pataka o gamit ani. Because there's also health and safety protocols that comes along with it. Number 2, environmental impact. The release of nanomaterials into the environment raises concerns about their potential ecological impact. The behavior and fate of nanomaterials in ecosystems are not yet fully understood. It is important to assess the potential risk and develop appropriate regulations to mitigate any negative environmental consequences. So kanina, na-mention na ko nga ang nanomaterials could also help to the environment. However, nalang sila mga paggagamitan ato sa environment. But that doesn't mean nga wala po na siya mga disadvantages. And ang mga disadvantages niya is mao na siya mga nakalista diri. Okay. Number 3, ethical and social implications. Nanotechnology raises ethical and social questions related to its potential impact on society. Issues such as equitable access to nanotechnology benefits, privacy concerns related to nanosensors and surveillance, and potential disruption of existing industries and employment patterns needs to be addressed. Okay, number 4, public perception trust. Public perception and understanding of nanotechnology can influence its acceptance and successful implementation. Responsible development involves transparent communication, public engagement, and addressing concerns. So, ang mga tao na nasa mga sarili-sarili mga opinions and understanding about nanotechnology. And it can influence sa pag-implement sa nanotechnology. Kaya ang mga tao, pag mao na ilahang hunahuna, di yun mo na sila mapugos. That's why responsible development involves transparent communication, public engagement, and addressing concerns. Ang mga tao, imbes nga mangutana, they are making assumptions to themselves. And it is not good. That's why we need transparent communication para ma-address ang atong mga concerns. 5. International collaboration. Responsible development and regulations require international collaboration and harmonization of standards. International collaboration can facilitate information sharing, best practices, and the development of common frameworks for responsible nanotechnology development. Okay, so ang nanotechnology is pwede na siya ma-abuse pag walay mga standards na ginasunod. That's why it needs international cooperation para magkaroon ng harmonization of the standards para malaman natin kung ano yung mga boundaries natin, if we have ever been gone too far or masyado na ba natin na-abuse ang nanomaterials. Kaya pag once too much ang paggamit nato sa kabutang or ang pag-abuse nato sa kabutang, therefore, muani pud ta sa iyahang mga consequences. And that's why, as of this moment, we need international collaboration to harmonize the standards as well as to facilitate information sharing and sharing best practices and development of common frameworks for responsible nanotechnology development. Because scientists are required to use nanotechnology with responsibility. And that ends my presentation. Thank you everyone for listening. Once again, my name is Lawrence Ivan Brakel from BSEd English 2A.